Hi all, I welcome you to the Building Culture podcast where I invite incredibly smart people who build things. Whether they be engineers, entrepreneurs, programmers, hobbyists, or researchers, it does not matter. As long as you're someone who's passionate about building things, I'll find you and podcast you. Hi, all. I want to take a brief moment to thank you all personally for supporting this podcast on YouTube and on all major podcast platforms, including Google Podcasts and Spotify. The podcast mainly features interesting people in robotics, artificial intelligence, and entrepreneurship. If you believe that the information that I'm providing might be of benefit to you or to someone you know, it would be really great if you could hit the subscribe button and press the notification icon so that you can get notified on time whenever the next part is out. It would literally take you a second or two to subscribe to the podcast, but it would really mean a lot to me because I can grow the podcast to a level where I can reach more people, invite ever more interesting guests, and have a more meaningful impact. So let's begin now.
In today's episode, I have the pleasure of having with us the founding member of FourthBrain, which is an Andrew Ng company that claims to make applicants learn machine learning in just 16 weeks. She's also an influencer and educator in the space of artificial intelligence and runs her own YouTube channel where she gives a lot of valuable and useful advice about how to get started with artificial intelligence, how to have an established career, and some tutorials and important technical information related to artificial intelligence. She is a researcher in artificial intelligence and has experience in applications ranging from autonomous driving to medical image processing. She is also an adjunct professor at the Santa Clara University in the San Francisco Bay Area. If I were to list all her accomplishments, it would probably take up the whole of podcast. So I'll just add a link to her LinkedIn account in the description. So without any further ado, let's welcome Sohini Roychowdhury.
Thank you so much for having me here. It's really interesting to find other AI based channels on YouTube and collaborate. So it's wonderful. Thanks for having me.
Yeah, thank you. The pleasure is mine. So let's start by talking about your personal journey into artificial intelligence. So could you tell us, like, when did you get introduced to artificial intelligence, your first association with it?
Well, my first association was in grad school, so that was back in 2008 fall semester, I would say. So I was back at Kansas State University, and our professor was Professor Sanjoy Das, and he had a class, and it was one of the hardest ones. So it was a PhD level class that I took in my first year of grad school, my first semester actually. So it was on neural networks. And that's where we started looking into chess playing. So we started with the prisoner's dilemma into game theory. Then we looked into chess, how to go about playing chess, making sure how would you go about the next strategy, and so on and so forth. We learned about evolutionary algorithms there. So my master's thesis was actually about epidemiology. So that time there was H1N1, swine flu was raging, and then there's this disease called foot and mouth disease. So it was about how do you figure out what are the locations that are the prime sources and how should they be cut off, and what should be the policies that are put in place so that people don't misuse it, but also it's how should people be remunerated or for their hardships that's going on. So coming up with all these decision-making processes for policy making, as well as for ensuring that the epidemic is contained in a timely fashion. So one of the very useful outcomes from our research was we found that this was at the time H1N1 was on, that the locations that were the main causes for widespread first was gas stations where people were not really sanitizing their hands before filling gas, and the second thing was playgrounds for little kids. So because that's where people will go, and the kids will hug. They won't think about it, right? So playgrounds and gas stations were based off of our research. We were able to see that the betweenness centrality of these locations were the highest, and so that was our strategy that if these places could be shut down, or people could be more cautious around them, then it would contain the spread. And I think that applies to any kind of pandemic, even in the world today. Like my suggestions are always be cautious around these locations. But it was amazing how very simple concepts can actually scale to so many different kinds of areas. And that's how I got into my niche, which is application. So I'm an application engineer. Most of my research contributions, even my research papers, are in applied AI. So how would you use an out of the box algorithm? Maybe the SOTAs or the state of the art algorithms would not directly scale for this new problem. What are the things you need to ensure so that it does? So it's all on the applicability and ensuring that a wider range of applications are met. So that was my first venture into AI.
Okay, and so after that you got after you did your master's thesis in epidemiology,
Yeah.
or however it is called. So after that you got more interested in this particular area, and you mentioned that you are more into the applied AI side. So what
That's
are
right.
the things that you further did in this particular direction, and how did you actually also come to know that this is the area that is of my interest and I should be like heading in this particular direction?
That was an interesting question, actually. Just out of undergraduate, you have your bachelor's degree and you don't really know where or what you're good at, right? But my principle is always the exclusion principle. Find the things that are not interesting to you, and then you'll automatically converge to what you're really interested in. So what I did was, right after masters, of course, we were using a lot of graph theory, so graph theoretical structures, in order to come up with the epidemiology at that time. When I applied for my PhD, I wanted to get into applied machine learning directly. At that time, there was no deep learning. This is somewhere around 2010 that I'm talking about, 2009, 2010. There was no deep learning then. SVMs were raging. Everybody was talking about support vector machines and how to use that in their systems. So supercomputers in universities were installed so that you could take care of that computational complexity. So when I applied to University of Minnesota, I got a 4-year fellowship to do my PhD, and that's when I saw that everybody was trying to use SVMs into their use cases. But again, my research became, so my PhD area was, I was always interdisciplinary. So my co-advisor was in the Department of Ophthalmology. And my PhD topic was automated, extraction, or automatically figuring out what are the features that you need to extract for retinal pathology detection. So looking by a retinal scan, how can you say what degree of pathology a person has? And because there was no deep learning, we were trying to go the normal machine learning way, extract features, hand engineering features. So I had to spend like 4-6 months with my co-advisor understanding what does he look for pathology in an image. So if I first understand what the manual process is, only then I'll be able to automate it, right? So that was my strategy, understanding how he understood pathology, and then trying to translate that into hand engineering features, and in order to then classify it. But deep learning came into being when I became a faculty after that. So I was a professor at the University of Washington, Bothell campus. My research lab was medical image processing systems. That's when deep learning came in. But the interesting fact is, even though deep learning has been here for about 5-6 years now, my paper is still the benchmark. So it's called DREAM, the diabetic retinopathy analysis using machine learning. So just because if you know hand engineering features, in order to get to the final accuracy is already high. I was getting like 95-96% accuracy. Maybe with deep learning you get 97 or maybe 97.5%. But that's it. So you can't really make a huge drastic change with deep learning, but again, domain knowledge was significantly important. And since then, that's been my area of research always till day, is not going the big data route, but the smaller data route is taking into consideration domain expertise and engineering features on top of that. So semi-supervised, unsupervised learning approaches, those are more topics of interest for me.
Okay, so you were more into domain specific, and so you had to know a lot of that particular field as well. And
Absolutely.
so the same, skill set can really not be applied to any other domain, because I mean you were not using deep learning at that time.
That's
So
true.
you are into applied AI, like applying artificial intelligence into lots of different applications. So
Yep.
after that, like, did you also work in other areas, and did you also have to gather domain knowledge as well around those particular areas?
Yes, but then what I would say is once you have the basic understanding of the framework, scaling, but once you know how to learn, learning something new is not that hard. That's the key, right? So when because I was doing medical image processing, and then a part of medical image processing was also to work with CT, MRI, different kind of modalities, right? And that's when I was making the transition from academia to industry. So back in 2017 I made that shift. So I joined Volvo Cars in their autonomous drive team. And at that point I was thinking, like, how should I make the selling point that I can do autonomous drive, which is computer vision, when I have a background in MRI and CT. But when the conversation with my manager was happening for my hiring, it was pretty evident that he was confident. It's like, you work with MRI, you know what point clouds are. We're using lidar. You should be able to scale that. So that's when I realized that in a lot of mindsets of experts in industries, like, okay, if you understand the modality, if you understand how to work with 3D point cloud, doesn't matter if you're looking at 3D CT scans or 3D MRI scans, you understand how to deal with the point cloud. So then apply the same thing, because I've done computer vision, but for medical perspective. If you know the same thing, then now apply it for something which is as broad as autonomous drive. It was a challenge, and I took it. But by then, I had already, because I was the 3 years that I was a faculty, I was working on this hyper parameterization. So I had a lot of research on Microsoft Azure, in order to automatically. So the as a domain expert, I would just feed in the data, and the network would automatically figure out. It's essentially what AutoML does today. The network would automatically figure out what are the best parameters. We were doing a grid search at that time, and what's the best model for it. So if it's a random forest, or if it is in a particular kind of classifier, that's the best for it. So it would come up with a pipeline for it. And because I had done all of that, then I was able to transition to deep learning from there. So at that time we were working on MNIST most of the time, MNIST and CIFAR data set. But having access to the code bases, I picked up TensorFlow at that time. Then TensorFlow Cafe was another one that was brewing. Keras was a subset. But again, when I had the hands-on experience, it was just applying that to computer vision, just for autonomous drive, and that came super easy. And once I got into autonomous drive, it was just following more of the CVPR papers, or understanding what are the key areas of interest. Like now I'm looking for lane markers. I'm looking for area under the road. I'm looking for objects such as cars, rather than I'm looking for pathology. So the modality shifted, the requirement shifted, because now in medical images, you cannot have a false negative. You have to, I mean, you cannot have a person who has pathology be sent home. It's okay to have a false positive, the doctor will take care of it, but you cannot have a false negatives. But on the other hand side, for autonomous drive, you cannot have a false positive. That means if you don't have a car and you're constantly saying car, 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 ding, 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 the driver's gonna get irritated, right? And then also it's a speed, because for medical imaging, I can just batch a data and say this is a very compute heavy, and it runs offline overnight and then gives you the results in the morning. That's fine. But for autonomous drive, it has to be real time, FPS. So how many frames per second are you computing? That is super, super, super important. So now all of a sudden we are not looking at two-shot object detection, but we're looking at single shot object detection. So the scope varied, but once you know what the scope is, once you know what the final outcome is, getting an algorithm, fitting the algorithm to that means is, once you know how to learn, you know how to pivot as well. So the basics should be there. After that, things just follow.
So it's quite interesting. Like what you meant is that you had worked with computer vision and point clouds and all these things specific to one particular domain. So you had the technical knowledge and using the tools essentially in one particular domain, and then you could easily apply it in a different settings. Of course, the requirements and a lot of other things would be different. And also, this is probably the thing, like when applying for industries. I'm not sure. So do they actually look for a previous experience in autonomous driving? I think that would certainly be impactful, right, as well. But you mentioned that as long as you have the skill set, you can transition from different from across domains as well. So
Absolutely.
what do you mean? What do you think about it?
Absolutely, and it depends on what level of expertise you have. Like I was a faculty. I was, it was like I 3 years post PhD experience in learning something new. So I think the putting the confidence is okay. You understand medical imaging, you understand computer vision, and scaling it to a new domain. That should be you. You should know how to learn, essentially. But on the other hand side, if it's just somebody fresh out of college, I think the importance on demonstrating something that is quickly applicable, because everybody wants the new hires to be up to speed on the first day itself. Like, from the next day the pressure is on. What can you deliver? What has the newbie delivered on the second day, or what has the newbie delivered on the first day? So and these kind of pressure situations do come up, and I see them quite often. When I was managing my team, I was trying to make sure that that pressure is curbed as much as possible. But it does happen, and in that case, if you're looking at an undergraduate project and showing that to be your placeholder into a new company, then yes, it has to be very much in that same domain. So GitHub, having a GitHub repo is way more important now, because the world has gone digital, than it was 6, 7, 8 years back, right? When I started the process. So right now, having so for instance, and because of my channel, AI with Sohini, I do get access to, or a lot of people ask me questions. One student actually recently asked me, okay, I want an internship in Intel. I have this background in medical imaging. How do I make sure that this project is something that helps me get that internship? So I gave him the advice that, why don't you look at TensorFlow Lite, because TensorFlow Lite ensures your models are very small. They are quantized enough so that you don't have a few 100 MB worth of model, but it's like very very tiny, which can be deployed even on your phone. And once you do the same process with your TensorFlow, let's say you have a model, and then you further quantize it using TensorFlow Lite, show that on your GitHub, and that should be good enough for any employer to know that now you know how to deploy something, and which is hardware compatible as well. So these are small considerations, I think, if you make. But yes, I would say the pressure is more on people who are just graduating and moving out, rather than people who are already in the industry. If they can scale an out of the box idea from from a previous domain to another domain, I think pressure is a little lower on them, but it is slightly higher on fresh graduates, I would say.
Yeah, for sure, for sure. And I mean, a lot of people are also making transition from different fields to AI, because AI is like everyone realizes how important it is, and the applicability of it is ever increasing. So, a particular question you must have heard from a lot of your students, and also the people who are following you on YouTube. So how does one make a transition from a different field, maybe mechanical design or electrical engineering, to artificial intelligence? Is it like mandatory to do a master's in artificial intelligence, or a related course, or can it be done on the person's, on an individual?
Self-learning, like self-learning versus, so it's self-learning versus supervised learning, essentially. But in the real sense, I always give the same advice to all the people who reach out, is there's no one solution that fits all. So it's, and although I've had a fully academic background before this, but I don't always say that you need to go back to grad school and get a master's, because that's not what works for everyone. Maybe it's not something that suits your budget or your time plan, doesn't matter which one it is. So and there are multiple ways to get into the field of AI. The first is you need to understand software and coding. You have to be good at coding. So if you are in a less coding intrinsic domain. And when I say coding, it's coding on platforms such as Python or C++, because that's more relevant. And in a lot of cases, I've seen people who have mechanical engineering background, they actually do have some Simulink and C++ background, which is helpful, which actually really helps, because a lot of autonomous drive, even though they are calling it machine learning for perception stack, they require C++. So it's actually a blessing in disguise, just using it in the right way. So I always say, go look into LinkedIn. What kind of jobs you really want to go for? And are they, entry level? So are you trying more into a test? Because understanding a test requirement or QA is different from a dev sort of a job. So look for what kind of jobs in whatever area you're interested in. Area, I mean location, geographic location wise, and find out, what are the requirements that people are listing. If a lot of the companies are saying C++ is required, then you should definitely do a side project on C++. But if you see most of them are saying Python, TensorFlow, PyTorch, then that's the area you need to go. So having coding experience is definitely a must. And it's not just writing code, it's reading code as well. So looking at GitHubs and going through, understanding quickly how to unpack the repo, where to put your data sets, and how to quickly achieve what the authors have already put out there. So reading as well as writing code, super important. And even for the early transition, I think a lot of the online courses are good enough. There are a lot of free versions is also available. I'm not going to name anybody specifically, but I'm just saying that there's a lot of free courses online that you can do in order to get into that. Once you have gotten into it, once you're already the beginner status is done, you've done a few courses, now you want to know what's next. Now, in order to get to the what's next, that's where you have a choice. Either some of these online boot camps, or where you get hands-on, working experience, as well as there's the career services to help, such as FourthBrain, could be helpful as well. Or you don't really need to invest money in these cases, just about self-discipline. And for this, I've even done a build your own research internship on my website. So it was a 10-week program. It was a self-paced, again, it's completely free, anybody can go through. So what I was doing is every Tuesday I would give out the assignment, and every Thursday I would give a sample assignment. So essentially I would do the assignment myself, and that was on advances of deep learning in medical imaging. So something similar, but for the domain of your interest. So doing something self-paced, but at the end, understanding that you need three things. A digital portfolio has three things. First, it should be well documented in your LinkedIn. You should have details of what you did on your resume, and you should also have a well done GitHub page, corresponding to that project. Once these three things are there, you can definitely shop that around in order to get an AI or ML applied role in the industry.
Okay. So one would start essentially by trying to first understand what one's interests are. For example, by browsing other people's profiles and job opportunities on LinkedIn, and then trying to figure out which direction one wants to go in. And then after that, one could for beginning, as you mentioned, like the courses that are already existing, they would give a good start on the fundamentals, and then after that one can decide whether one wants to go deeper in one particular domain, or one wants to explore more and other things. And yeah, I think the thing that you mentioned about creating a GitHub profile and demonstrating what you know already to the employers, I think that would be one of the key takeaways from the whole advice that you give.
Absolutely. And it's super important. I mean, you can, in today's world, you cannot get away without having a GitHub, repo, and several of them with the proper commits, with the proper documentation. So the README file is super important. So putting everything in one place, and polishing that so that that's what you highlight when you have your first call. So I recently did a video on my channel as to how to ace the first technical job interview call, and that's where I talk about all the questions that are asked. And how to prepare for them. So is it always your favorite project, or should you highlight the project that you think is more applicable to the company directly? So how would you go about it? So yeah, these are all pointers that I shared on my channel, I guess.
Yeah, and maybe you can also introduce your channel a bit, what are the kind of things that you share? I mean, I briefly touched that you give career advice and
Mhm.
other things related to AI, but maybe you can like formally introduce what you share and for what kinds of people would this be beneficial to?
Yeah, so I started my channel back in the end of May 2020. And again, that time I was calling it Career Coach Sohini, because when I started it, it was just my way of sharing with the community what are the advices, tips and tricks and strategies that I have for changing your career. Because if you're trying to switch a job, and doesn't matter if you're fresh out of college or if you have a few years experience, or you've been working in industry. So I it was more towards people who are already in the MLEI domain, for them how to make the change. So that was what I had initially intended it for. And that's when I put this build your own research internship. But then what I saw was most of the subscribers, when they started getting back to me, they were people who were getting into ML for the first time, AIML. And that's when they started asking, okay, what are some of the basic concepts? What are the basic tools? What should I be aware of to even get started? And that's when I said, okay, let's pivot. So once I finished that 10-week program, I started pivoting. So I have this playlist on AI concepts and tools. So if it's introduction to TensorBoard, or and in 2020, TensorFlow also launched their TensorFlow 2.0, right? So most of the code bases that work on TensorFlow 1 will not scale down to TensorFlow 2. So how to give support to those people? So I did a lot of coding examples, examples on regression, sample collabs on TensorFlow 2.0. And at that time I was also getting a new computer. So that's something that anybody who's dabbling into deep learning and AI/ML requires, a strong computer. And I was looking into a strong computer as well, and I found that typically people go for the Dell and the HP, but there was this one company called System 76. It's one of the cheapest one with the best specs out there. So when I bought it, I even did a unboxing video, and also I keep doing updates on my system and how it's working for the deep learning applications. And then from time to time, it's career strategies, how to ace your interviews, how do you go about structuring your GitHub profiles. It's mostly I think it's based off of, so what people what I've seen is people, when they subscribe, they also connect to me on LinkedIn. And I get a lot of questions from LinkedIn, how to do this, how to do that, and based off of that I pool them together and I create my videos from there. So that's essentially, so it's not meant for anybody who already is into the IML anymore. It's more about starting, people who are starting out, or if they want to know what kind of laptops to buy, or how do you even work CUDNN on a System 76 Ubuntu 20.0 system. And sometimes I talk about system design, for in the interviews. Sometimes I talk about, the actual coding round. So these are some of the videos that I'm planning in the coming weeks, like HackerRank or Codility. So if somebody has to, ace those interviews, then how to go about it. So yeah, everything to do with in and around the AI careers, I would say.
Okay, so essentially for all the questions that people who are beginning with artificial intelligence, machine learning, and these areas, have you address all these questions? And I think one particular thing that probably holds back the people who are starting is also the idea that you would have to have a very powerful system. And you mentioned that you also give advice on which kind of what should the specs be, for example, for a laptop. So for a beginner, do you think one should actually purchase a high-end laptop, or
No,
one can?
no, I do not. And that's why, so I even did a short tutorial on Colab. So now that, these cloud platforms are at our fingertips, just launching a Jupyter notebook is super easy. And you don't even need a paid profile for that, right? So understanding how to go about Colab, or if you're looking at Binder, or if you're looking at, Kagel's, offering. So how do you even launch a Jupyter notebook? So I went through all of that, and I even had a video on AutoML. So let's say AutoML, and people think AutoML is just AWS or the cloud solution, but that's not true. There are AutoML solutions called Teapot. You can even install that in your Google Colab if you want. So there is sklearn, AutoScaler, there is Teapot. So what happens is, you may not have any ML background. You have this data set. You just know how to do a train test split and just feed it into AutoML. It will find the best network and the best hyperparameters for you.
Wow. So you don't really have to do anything.
But I always teach it at the end once I've taught actually the supervised unsupervised model, because there's always this issue of sensitivity to the data set. So maybe if you've passed the 70-30 split and you've passed it through AutoML, you might just get great results for that one split. But once you generalize it across more splits, you might see the performance has deteriorated, or it's not even the same model anymore. So it's useful to know these AutoML solutions once you know what they're doing. Just knowing AutoML, that you just blindly put things in is not good. So like with great power comes great responsibility. So yeah, and I had a video on Teapot as well, how to use auto sklearn and AutoML as well. So all of the models and methods apply together, I would say.
Hey guys, I really hope that you enjoyed this particular conversation and it helped you in some way, shape, or form. If it did, make sure to hit the subscribe button and the notification icon or the bell icon so that you can get notified on time whenever the next part is out. Also, it would be really great if you could give me your feedback in the comments below. That would really help me improve. I'm uploading small clips of the long podcasts on a regular basis on platforms like LinkedIn, Facebook, and Instagram. So make sure to follow me on these platforms if you're someone who cannot take out time for the long episodes. The podcasts are also available on all major podcast platforms, including Spotify and Google Podcasts.